Okay, looks like we're ready. So I have the original 3 exams and the study guide from the last exam. What would you like to focus your time on to start with? Yes?
I think it was like on the third exam. Yeah, the very last one. But I still understand the part of it.
So the very last question.
Yeah.
So we are looking at a sum. And there are 2 parts to this problem. One is to find the value of the sum, and the second is to find the limit of the sum. Okay? So for summation, we have some basic formulas, and then we have some properties. And for this problem, what I want to do is I want to multiply it all out so that I can apply linearity. So let's see what I can multiply out. Let's see, the 2 is going to distribute, so we can rewrite this as a sum. K goes from 1 to n of 2 plus 6k over n minus 1 times 3 over n, and now I'm going to distribute, well, actually, let's simplify. 2 minus 1 is going to just be 1, so we'll distribute the 3 over n and the 1. K goes from 1 to n of 1 times 3 over n plus 18k over n squared. So what have we done? We've taken the original summation and I've simplified it into a much simpler form. And now I'm going to use linearity because it's written as a sum of 2 pieces. I can split it into 2 parts. The sum, k goes from 1 to n of the constant, 3 over n. And then 18 over n squared is a constant, and I'm going to factor that out, leaving just a sum of k, with k going from 1 to n. Now the advantage of this is that we have specific formulas that we know whenever I add up a constant, that first term is 3 over n times how many terms? N. Then I get plus 18 over n squared, and I also know a formula for this summation. It's n times n plus 1 over 2. This is the value of the sum. Now we could simplify it slightly. The n's here cancel. One of the n's here cancel. And the 18 over 2, that simplifies to just 9. So I get 3 plus 9 times n plus 1 over n. This is the answer to the first part of the question. It's the value of the sum. Okay, so I'm going to write that up here so that we have it recorded for us. 3 plus 9 n plus 1 over n. And I'm going to erase the rest of the work. Okay, so I expand the terms all the way out, and then I use algebra to be able to figure out those other pieces. When we want to calculate the limit of the sum, we're taking the limit of our formula. Yes?
There you have 3 plus 9 times n plus 1 over n, and I went further and took the n out.
Yep, you could write this as 3 plus 9 over n. Is that what you mean?
Well, I have 3 plus 9 in parentheses 1 plus 1 over n. So I took
That's also correct. I was about to get to that for this other version as well. So let's see where that comes from. So when we studied sequences and the limits of sequences, we learned that if I have things going to infinity on the top and the bottom, we had to cancel them out. We had to factor them out. So what we're going to do is we're going to factor out the highest powers. And this time it's just n. So let's rewrite this. 3 times 9 times n plus 1 over n. So if I factor the n out, that means I'm going to divide. N divided by n is 1, plus 1 divided by n. And then n is already factored out on the bottom. And so when I cancel out those n's, this is where we got that other version. Okay. So when I take a limit of that simpler version, what happens to a 1 over n when n goes to infinity? 0. 1 over infinity is 0. And so we get 3 plus 9 times 1 plus 0, which is just 12. Okay, so that's the limit of the sum, which would happen to correspond to, this is a Riemann sum for an integral. Whatever that integral is, it had a value of 12. Okay? All right. So this is very similar to a question that's on the Since Exam 3 review. Where it says use a Riemann sum to find the integral. So let's review how I find a Riemann sum. A Riemann sum requires calculating delta x, which is always b minus a over n, x sub k, which is always a plus k times delta x, and then we use f of xk in the Riemann sum. K goes 1 to n, f of xk times delta x. So for this problem, my delta x is 4 minus 1 over n, which is 3 over n. That corresponds to the width of my subintervals. And my x sub k are equal to my starting point plus k times delta x, which is 3k over n. And we're going to plug this value into my function to get a Riemann sum. So my Riemann sum is the sum k goes from 1 to n of 2x plus 3 times 3 over n. So you can see that this is almost identical, except for the numbers, to the problem we just did. Okay, so if on a test I ask you, find the Riemann sum, this is what I'm looking for. I just want you to write that down. So this is the Riemann sum. If I ask you to find the value of the Riemann sum, then I want you to actually expand it like we did on the previous problem and get a formula in n. So if I ask for a value of a Riemann sum, then I want you to expand it and use formulas. Right, so here I have a sum, k goes from 1 to n. What do I get? 2 plus 3 is going to be 5, plus 6k over n, times 3 over n. Now I would want you to expand it out. K goes from 1 to n of 15 over n plus 18 over n squared, sum k. And as soon as I used the formulas for the summation, I found the value of the Riemann sum. So 15 over n times n plus 18 n times n plus 1 over 2n squared. This is the value of the Riemann sum. And the integral would be the limit of this value. Okay, so I would simplify this as much as I could. The n's cancel. 18 over 2 gives me 9. N over n squared. One of those will cancel. So a simplified version of our formula is 15 plus 9 n plus 1 over n. By the way, you should be able to see the value of the limit without necessarily doing all the algebra. Right? 9n over n. The n's are going to cancel. I'll just get a number 9 for the limit. So that's the value of the Riemann sum. So this was equal to 15 plus 9n plus 1 over n. And the integral is the limit of the sum. So this is going to work out the same as last time. 9 times 1 plus 1 over n. And goes to infinity. I'll get 15 plus 9 is 24. So that's how I get the value of the integral using a Riemann sum. We have a different way of doing this one, but that's how I would do it using this strategy. All right. What else did someone have a follow-up question or another question?
This is a question about this.
Yeah.
Why couldn't you just distribute the 9 into like 9n plus 1 and then
You could. You would have had 9n plus 9.
and then you would do like the n's cross out and you get 9 plus 1 is 10 and you do 25.
No. And the reason is that you can't cancel because that's the wrong order of operations. This is plus. You can't cancel a division through an addition, right? So that's why. I mean, it has to be factored. It has to be multiplication, not addition. Is there another question? Yes?
Is that something different? Like, on
That's
the
fine.
same exam, when
Uh-huh.
it says like find the position has to be in the velocity of the first part and clear the out.
Uh-huh.
It's like 5C. How can you figure that out?
Let's see. My exam maybe is all messed up. Okay, so it was which problem?
Number 5C.
Oh, yeah. Okay, so this problem, we started with a graph of the velocity. So this is exam 3, problem 5. We have so this is a graph of my velocity. And we did an integral from 2 to 8 of my velocity, which corresponded to here to here. Okay. And your question was not about defining the value of the integral, right?
I was just about how you find the position of the recipe.
Okay. So the value of the integral was negative 4.5. All right. So that question has to do with something really, 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 really important. And that is when you have an integral of a rate. Integral of a rate of change. What's that always equal to? That's a geometric interpretation. We've got to get the physical interpretation also. It's the total change. So this is always equal to the total change of the quantity, not the rate. Okay, so velocity is the rate of change for what kind of measurement? Here's a hint. It's in meters per second. The numerator is the quantity, so it's the rate of change for position, for distance. The bottom is time. That's what I'm measuring it with respect to. So when I integrate velocity, I get the change in position. This is the change in position, which means the position at the end minus the position at the beginning. And it's always that order. It's always the ending value minus the starting value. So what that means is I know that my position at time 8 minus the position at time 2 is equal to negative 4.5. And I'm given some information that at time 2, my position is 5. And so I'm going to put 5 in the formula. S of 8 minus 5 is equal to negative 4.5. And I'll just add 5 to both sides, and S of 8 is where I started, minus 4.5. I'm at 0.5 meters. Okay, so there's a follow-up question related to that on the review. So this is the topic since exam 3. Second section, problem 2. We're told that my velocity is given by a formula 4t, t minus 2, t minus 5. We're told that my position at time 0 is 20, and our task is to find S of 5. So if I know the velocity, how would I find the position? It's the principle we just talked about. The integral. The change in position, S of 5 minus S of 0, is the integral from 0 to 5 of my velocity. In fact, I can add S of 0 to the other side. S of 5 is equal to where I start plus the integral from 0 to 5 of my velocity. So let's write that down. S of 5 is 20 plus an integral from 0 to 5 of my velocity formula, 4t, t minus 2, t minus 5, dt. So my position at time 5 is where I start plus how much I change. And the integral gives me how much I change. Well, since the last test, we've learned some rules about how to find that integral. And so we have some basic formulas that would be provided. They will be on a formula sheet as part of the test. That if I have an integral from 0 to a of 1, it's a. If I have an integral from 0 to a of x dx, that's 1/2 a squared. If I have an integral from 0 to a of x squared dx, that's 1/3 a cubed. And if I have an integral from 0 to a of x cubed, that's 1/4 a to the 4th. So we can use these four formulas as long as I can split that integral into those parts. So what I need to do is I need to expand by multiplying this all out. I'm going to leave a little space so I can just substitute up there. The integral from 0 to 5 of 4t times t minus 2 times t minus 5 So let's use FOIL. So I get t squared minus 5 and 2, so that's minus 7t. Plus 10. Can I use the formulas yet? No, because it's still multiplying. I have to only be addition for linearity to work. So I have an integral from 0 to 5 of 4t cubed minus 28t squared plus 40t and now I can split it up using linearity into 3 parts. I'm going to get 4 times the integral of t cubed minus 28 times the integral 0 to 5 of t squared dt plus 40 times the integral 0 to 5 of t dt. Now the letter in the variable doesn't matter, so whether it's x or t or anything else, the rules are the same. So my position is going to be 20 plus 4 times t cubed, that's 1/4 5 to the 4th minus 28 1/3 5 cubed plus 40. See, maybe I should put extra parentheses so it's clear what I'm doing. 40 times a half times 5 squared. So that value would be the value of my new position. This piece is the integral that I found, and that's the change. If I add it to 20, that's my new position. So is it clear how I'm going from using those formulas for this last step or not? Are there some persisting questions on this one?
So that would be the value.
Yeah, once I get these, whatever this number is, I don't have a calculator, so I'm not going to do it. But this will be a number, and that's my new position. Okay. Your project had a related thing, the river flow. The column that was given was a rate of water flow. When you multiplied it by the 15 minutes, you suddenly had amount of water. That's the change in the water. And when you did the sum, you found the total change of water that flowed through the river during the month of February. So it wasn't a rate anymore, it was an actual amount of water. Okay. All right. So what's the integral of a rate? If I do a definite integral of a rate of change, it's the if it's the rate of change of position, right? So it's a total change in the quantity that the rate represents. Okay. Do you have a question?
Yeah, I got this question right. I think it was exam 3 number 2. And I got it right because it was on the study guide in a very similar way. But I'm not really sure why it breaks down to like 1/3, 1/9, and other things. Can you just explain what's going on there?
So this is the sequence that we need to make decreasing and concave up. Or is it? So for any of you who came in late and missed my explanation of why I'm blocking part of the board, this is being streamed live and will be immediately posted on YouTube after we're done, so you can go back and review the problems. So sorry that it's in your way at the moment, but hopefully that's a fair cost for having something like that. Okay, so we are looking at the following question. We want a sequence that is decreasing and concave up. Okay, so we're looking for a sequence that is decreasing and concave up. Now, this is strongly connected to the things we've been doing since the last exam related to increasing and concave up functions. Okay? So, if I want a sequence that is decreasing and concave up, what is it that makes a sequence decreasing? What? Negative what's? Negative increments. So I need negative increments. What does it take to get something that's concave up? Increasing what's? Increasing increments. So the word increasing is not enough. I need increasing increments. Okay. Now the symbol that we use for increments, if my sequence is U, then my increments are written with the upside down delta U. So what do we know? We know that my first increment's -3. What else do we know? I know my first value, my 0 value of my sequence is 5. Okay. So I need a sequence of increments that stay negative, but they're increasing. And so increasing here has to do with true inequalities, not getting bigger in size. And so I need to be going to the right on the number line. So here's my number line, here's -3, here's 0. I need to be steadily going this way to be increasing, and I have to stay below 0 so that I stay negative. So give me another increment possible. Okay, so your specific question, if it involved 9ths and 27ths, what you probably did is you just divided by 3 each time. So this is one possible way of getting a sequence that is negative and increasing. I'm just going 1/3 of the way each time, getting closer and closer. But that's not the only way to do it. As long as I see that you stay negative and I'm increasing, it'll be a valid answer. So I could have done -3, -2, -1, -0.5, 0.4, 0.3, 0.2, 0.1, 0.05, 0.04. As long as it's obeying this rule that it stays negative and is increasing for the increments, it'll be fine. So if this is my sequence of increments, then my sequence for u, I need to subtract 3 for the next value. And then I need to subtract 1 for the next value. And then I need to subtract a third. So I'm in 2/3 now for the next value. And then I would need to subtract 1/9. So now I'm getting in trouble. 6/9 minus 1/9 is 5/9 for the next value. And then I need to subtract a 27th. And so this is 15 minus 1 is 14 27ths. And so this sequence that I've created the start of is decreasing and concave up. Okay? So how does this relate to the things we did since the last exam? Well, instead of sequences that are decreasing and concave up, we've been looking at functions that are increasing and concave up. And that was based on the idea of using integrals to represent accumulation. So let's see if there's a yeah.
Oh, I was wondering if you could go over another question that was on the first example.
Let me try to make this quick connection. So when I have a function this function that's being integrated is the rate of change of the rate of accumulation, sometimes written a prime. And the idea is, if I understand where this function is positive and negative, I know where the accumulation is increasing and decreasing. If my rate is increasing, my accumulation is concave up. Okay, and so we had some practice looking at functions that are related to that. So I just wanted to make that connection. What do you want to ask about?
On the first exam, we have a 12. So that's the question.
First exam. All right. So this is exam 1, number 12. We have t is an exponential function of t. T is the number of years since 2000. We have the following table: year, population, 2005, 2015, 1200, and 2400. Okay. All right, so what we need to do is we need to translate this into a function of t and p. So T is the number of years, P is the population. And so my population numbers are the same, but I do have to think about what the year is. So at 2005, how many years has it been since 2005? So here T equals 5, and here T equals 15. Okay. All right. What does exponential function mean? So to say that it's exponential means the population is A times B. Here my variable is T, not X. A times B to the T. And so this problem is an example of a problem where we're practicing finding these parameters. So A and B are called the parameters. And we're going to find their values by plugging in these two data points to find it. Now, some of you in other classes have learned a different way of writing exponentials, and if you do this, it's fine. Where you write it involving the natural exponential e. And now here the parameters are a and k. But I didn't focus on that way because I really wanted to emphasize this strategy. If you do it the other way, you're perfectly fine as long as you do it right. But I'm not going to go about that other way. So each data point gives me an equation. So 1200 gives me 1200 equals A times B to the 5. And the second gives me 2400 equals A times B to the 15. Now our strategy for these problems is I've got an equation with two parameters. I'm going to solve for one of them, and the easiest one is to solve for A by dividing both sides by B to the 5th. And so I'm going to find out that my A is 1200 over B to the 5th. And I'm going to use that in this other equation. So this A, I'm going to take the value. So I get 2400 equals this 1200 over B to the 5th times B to the 15th. Now, the B to the 15th divided by B to the 5th, I use the properties of exponents and subtract. 15 minus 5 gives me 10. I can divide both sides by 1200, and I get 2 equals B to the 10th. So how would I go about finishing solving that? If I have B to the 10th equals 2, what's the inverse operation of a power? That would be the inverse of an exponential. If the variable was in the exponent, I would use a logarithm. What would you do if it was b squared equals 2? We take a square root, but this is the 10th power, so I take a 10th root. And so I get my base, b, is the 10th root of 2, or 2 to the 1/10. Now that I know my base, I can write A is 1200 over this base to the 5th power. So 2 to the 1/10 to the 5th power. Again, what's the property of powers? If I have 2 to a power, all to a power, those are going to multiply. So I get 2 to the 5/10. So I get A equals 1200 over 2 to the 5/10, 2 to the 1/2. Okay. So that gives me my final formula. My P is going to be 1200 over the square root of 2 times 2 to the 1/10 to the t. I can just multiply that out there. Or t, the 2 to the t over 10. Yes?
Can you explain the number 5, the number 1? It's the inverse function of A.
Yes. All right, so the first, I have a function with 2 variables, and so what this is saying is it's saying that A is my input, C is my output, and so my equation is C equals 4A over A plus 1. Okay, so notice here, C is a function of A. To find the inverse function, we want to solve that equation and write A as a function of C. So to find the inverse, we want to solve for A. Okay? So it looks complicated because there are 2 A's, but we're going to start by cross multiplying. So I get C times A plus 1 equals 4A. And then I'm going to distribute this side. So I get C times A plus C equals 4A. Now I want to solve for A, so I'm going to group all the A's together. I'm going to put all the A's on one side, so we'll subtract CA from both sides. And so I get C equals 4A minus CA. Now, it almost looks like I've solved for C, but have I solved for C? No, because C is on both sides of the equation, so I actually haven't solved for C. But the advantage of writing it this way is A is a common factor now. So I can factor it out. Let's come up here. C equals A times 4 minus C. And now that it's a multiplication, I can divide both sides by 4 minus C. And I've got A equals C over 4 minus C. I've written A as a function of C. And this formula defines my inverse function. What's the input? It's C, so it's x over 4 minus x. That would be my inverse function. Okay. So inverses are you solving for the other variable? What else? Yes?
On exam 2, the first question,
Yes. So this is a transformation question. We had an original graph. And a transformed graph. And we want to find out how to write this function as a transformation of this one. Okay. So what we do is we think of our original axes as our x and our y, and our transformed axes as u and v. And what we're wanting is we're wanting a composition so that I start with u and I end with v. So I'm looking for a composition like this. And what that means is I need to find a rule that says, what's the relationship going from my u values to my x values? Okay. So let's see, what do we have? For my u values, I have this point, 0. That point is supposed to match this point, and so that corresponds to an x value of 2. Well, there's got to be something else that's related. You have to have 2 points to find a line. So the second thing is going to be the vertical asymptote. And so the vertical asymptote is taking place at -2, whereas here, the vertical asymptote is taking place at x equals 0. So -2 and 0 is my other point. So this is from the point, and this other is from the vertical asymptote. And I need to find the equation of a line that goes through those 2 points. So how do we find the equation of a line? Find the slope. So the change in x over change in u, output over input, is 0 minus 2 over -2 minus 0. And so I get -2 over -2 is 1. My slope is 1. And I need to pick a convenient point. Let's pick this first point. X minus 2 equals the slope times u minus 0. So that's just u. X is equal to u plus 2. That's the first step of my composition. X equals u plus 2. X goes to y, we already know. That's 1 over x. Now the idea of composition is that we're just taking this formula and we're substituting it in for x. To finish it, we need to have the last rule. What's the relationship between y and v? So those are my y values. So I look at this graph, and what are the two y values I know? I know the point at 1/2, and I know the horizontal asymptote at 0. So where do those go in the new function? Well, the point goes to 0, and the asymptote, what do I say, is at 5. So those are the two values of the y coordinates that I know. And again, this is supposed to be linear. So I'm going to find the slope. Output, change in output over change in input. 5 minus 0 over 0 minus 1/2 is 5 over -1/2. That's -10. So my slope is -10. And we pick a point. Maybe I avoid fractions. Pick the second one. So v minus 5 is -10 times y minus 0. So that's -10y plus 5. Okay. So this is the last step. V is -10y plus 5. I want space so that we actually get our answer in here. So V is -10y plus 5. And so we're going to take this formula and plug it in for y. -10 over u plus 2 plus 5. So that's the equation of the new graph. Although we probably want to think about it as y and x, because u and v were sort of just temporary placeholders. And so this graph would have an equation y equals -10 over x plus 2 plus 5. Yeah, great.
Would you take the top of the x and like do you change it from u to v to y?
If I ask specifically for it to be x and y, then it would be a very small fraction of a point. So yes, I would have to take a little on. But that getting to here, you get like 95% of the points. All right. So that's how transformations work. We're just finding the linear relationships on the x values and the y values, and then we do a composition to get our transformation. Yes?
Can you do number 3, part B on the same text?
Let's see. Exam 2, 3, B. This is defining a sequence explicitly?
Yeah.
So let's see, I have a sequence 6, 9, 12, 15, 18, and on and on. In order to answer the recursive one, the explicit one, we have to look at the recursive formula too. So part A was to define the sequence recursively. Okay. So that corresponds to describing the pattern that we see. So what pattern do you see about this sequence?
Sorry.
We're adding 3 each time, right? Okay. So the recursive formula is my next term in my sequence is my current term plus 3. That's my recursive formula. And I also have to say where I start. And this is connected to what we did in the last little bit of the class about seeing when sequences are equal. They have to have the same initial value and the same increments. Well, this is the increment. They have to have the same initial value. And here we have an initial value of 6. So part B is to define the sequence explicitly. And so you're supposed to recognize that this is an arithmetic sequence, which means that my explicit formula should be linear. If it was geometric sequence, my explicit sequence would be exponential. So there's this connection for those two. Now, if I were to look at my formula, the first value was 6. And the second value, how did I get the 9? Well, I added 3. And the third value, I added 3 twice. And the fourth value, I added 3 times. And so there's a pattern that's showing up. I'm adding up some number of 3s. And this, my increment is the slope. And so I'm looking for an equation of a line that has slope 3. So we could write down an equation xn minus 6 equals the slope times n minus 1. So this is a point slope form where xn plays the role of y and n plays the role of x. So here's a point. That's like y equals x equals 1, y equals 6, except that it's n equals 1 and x n equals 6. So it's a y minus the y value equals the slope times x minus the x value. It's always the same thing, and I'm going to add 6 to the other side. So my explicit formula is 6 plus 3 times n minus 1. Which you could also get by looking at the pattern. When there was on my third value, I had 2 3s. When I was on my fourth value, I had 3 3s. That's why it's 3 times n minus 1.
Why is it n minus 1 not plus 3?
Well, it's n minus 1 because the slope, point slope form is always y minus b equals m times x minus a. And so here it's my, if I thought about it as a data table, n xn 1 6 2 3, sorry 2 9, 3 12. Here's my x value, here's my y value with a slope of 3. Okay. All right, I think that, yeah, that answers that question. What else? Yes?
You do 5B, so you do.
Same exam, problem 5B, finding limits. All right, so part B, we're finding the limit And when for sequences, we're always thinking, whenever we're talking about limit, we're talking about n's going to infinity. All right, so what happens to 3 to the n when n goes to infinity? It gets bigger and bigger, right? And so this is going to go to infinity. So if I were to think about this intuitively and ask, okay, what happened to all the terms? I would see that Cn is like 4 plus infinity over 2 times infinity. So what's 4 plus infinity? It's infinity. What's 2 times infinity? Infinity. What's infinity divided by infinity? Nobody knows. Okay, so you cannot cancel infinities. Okay, so we don't know. And so the point of this problem is whenever you see things where you have this infinite thing, what we have to do is we have to somehow, before we take a limit, cancel away that biggest power. So before the limit, we need to cancel away the whatever it is that's getting big so fast. And in this example, the thing that's getting big is 3 to the n. So I have to cancel 3 to the n from the top and the bottom. So 4 plus 3 to the n divided by 2 times 3 to the n. Now the reason that most people had trouble with this is they didn't know what to do with the 2 times 3 to the n in the bottom. I'm just thinking back what it was. So I'm going to factor out 3 to the n from the top and the bottom, which means I'm going to divide the top and bottom every term by 3 to the n. So I get 4 over 3 to the n plus 3 to the n over 3 to the n is 1. Okay? Now, how many terms are in the denominator? One term. And this is why I think there's an issue. When we talk about terms, we're talking about things that are added. So there's only one thing in the bottom. And so when I factor out 3 to the n, I'm taking this one thing and dividing it by 3 to the n. Now the advantages, that's simple. 3 to the n's cancel. And so we get a new formula for my Cn. It's 4 over 3 to the n plus 1 over 2. Now what happens when n goes to infinity? What happens to 4 over infinity? It's a 0. Plus 1 over 2. And so this is 0. And I get a limit of a half. That's how that works. Okay? Do you have a persistent question there, Alyssa?
I was confused as to like on my exam, I didn't know that that was the full term, so I divided them both by 3. Fair.
Right, so that would be like if I factored x out of 4x, that somehow you factor x out and you say that's 4 over x times x over x, which is, I mean, we don't do that.
Yeah.
So, all right. So there was another question. Should we do part A, the same one? Okay. So here we had a sequence, 3n plus 2n squared over 1 minus 5n squared. As n goes to infinity, I get 3 times infinity plus 2 times infinity squared over 1 minus 5 times infinity squared. So let's think about what happens to all those pieces. What's 3 times infinity? Just infinity. What's 2 times, what's infinity squared first? Infinity times 2? Infinity. 1. What's, we already know that's infinity. What's 5 times infinity? It's infinity. And so let's see, what do I get? I get infinity plus infinity is infinity. And over minus infinity. And again, we're stuck where we can't, that's not a valid thing to stop at. We don't know what that is. So this is called indeterminate. So again, we factor out the fastest growing piece. So for this one, what do you think should be the fastest growing thing? N squared. Highest power. So this is the highest power. We're going to factor that out and rewrite an as n squared times, there are 2 terms, so it's 3 over n plus 2. On the bottom, I factor out n squared from the 2 terms. I get 1 over n squared minus 5. N squares cancel. And now I can ask, okay, I got rid of all the dominant growth, and so I get 3 over infinity plus 2, 1 over infinity minus 5. That's a 0, that's a 0. I get 2 over negative 5. And so what I find is that my sequence has a limit of negative 2/5. Which corresponds to just thinking about that dominant term, 2n squared over negative 5n squared. Okay, the rest didn't matter. All right, so we finished that problem. What else? Yes?
Exam 1 number 9.
All right, exam 1. Is this the PCR one? All right. Okay, so it's probably not meaningful for me to copy up the whole problem. But what do we know? We have a PCR and microarray. Okay, so one PCR costs $85. One microarray costs $60. We have a maximum budget $5,000. Okay, so then we have the following statement. Data collection requires twice as many PCRs as microarrays. and we want to know how many runs to do. Okay. All right. So part one, and I think actually that this was a harder part for a lot of students. What should we think of as our variables? Yeah, great.
The number of PCR runs and the number of micro
The number of PCR runs and the number of microarray runs. Those are the variables. And we need to give them some symbols. Okay? So, you know, one simple one might be to just call it P and M. P for PCR and M for microarray. Okay? Now, interpreting this sentence leads to an equation. And twice as many often throws students. They put the 2 in the wrong spot. So you'll always be safe if you think about creating a little table where you say, okay, let's use natural language. I need twice as many PCRs as microarrays. So if I have 10 microarrays, how many PCRs will I need? 20? And how did you get that? Multiplied by 2, right? And so that's actually our equation. P equals 2M. That's one of the equations. Okay, that's one of the equations. So we've used this piece to give me an equation. How do I get another equation?
something that you can find out.
The total cost. So how would I find the total cost? See, that's actually a new variable. How would I find the cost of doing 20 PCRs and 10 microarrays?
Probably an 85 for P and 60 for M.
What do you mean by that? You want me to change the 10 and the 20 to 85 and 60?
And as I said, for each PCR, it's $85, and for each microarray, it's 60. So you just add together, like how many, the number of microarrays multiplied by 60, and then the number of PCRs.
Right, so our cost is, we're not changing this to 85 and to 60 and adding the numbers. We're using, like if I knew that there were 20 PCRs and if each one cost $85, we would know that I need to take $85 times the number of PCRs. And I would have to add $60 times the number of microarrays. I don't, these are not the number of runs. These are something separate. They're used in another equation. So my second equation is $5,000 is the total cost. That would be my second equation. I need to run and get some water. Think of a new question.
equations are your final answer, like you need both.
Correct, I need two
Well,
equations.
this takes into consideration twice as many, so this takes into consideration.
Right. So if I were solving this system, then I would use one equation, change the p in the other equation to 2m. And then I could solve for m, and then I would then know how many p's I used. But yeah, this was specifically focusing on writing down the equations, not necessarily
So I
solving.
tried to like combine both of them.
Right. Yes.
Have you already gone over number 7B on the second exam?
No. This is the population. Okay. So this is exam 2, problem 7. So I have a way of defining a sequence recursively, and part B says this sequence is converging. What is the limiting value? So Pn is converging. Find the value. And that does not mean just tell me what the decimal value is. I want to know the formula of the exact value. Okay. So when I have a recursive sequence that's converging, it must be converging to a fixed point. Okay? So what that means is this is really a question about finding the fixed point for a projection function. So what is the projection function? It's the function that's taking the old value and using it to predict the new value. So let's see, here is where my old value is being used. And so it's 3x e to the minus x. And we want to find the fixed point. That's where the input is equal to the output. In other words, the sequence, my old value and my new value are the same. So we're solving x equals 3x e to the minus x. So there's a lot of x's in this problem, and I better not cancel. So what I'm going to do is I'm going to subtract x to the other side. Which allows me to factor. It's now a common factor. So there are two possibilities. Either x equals 0, or this other piece, 3 e to the minus x minus 1 equals 0, which I can solve. Let's see, add 1, divide by 3. So I get e to the minus x equals 1/3. How would I solve a problem with e to the minus x equals 1/3? Yeah.
So x equals n 1/3.
I use the logarithm equivalent, so be careful. The input here is minus x. So minus x is the logarithm of 1/3. So x is going to be, put the negative sign on the other side, negative logarithm of 1/3. Now, I could think of this as being a -1 times the logarithm of 1/3. So that negative can go inside as a power. So what's 1/3 to the -1 power? It's not a calculator question. What does a -1 power do? Reciprocal. So this is equal to the logarithm of 3. Yeah.
What the same way if you put it in the calculator, negative ln 1/3?
Yeah, but then you'll get a decimal value again. I'm looking for an exact value. So I would have accepted this as an exact value. And this is an exact value. They're equal. So there are two possibilities. In the earlier part of the problem, you would have found some values of the sequence. And you would have seen that one of your values was like 1.09 something. If you take that value log of 3, it's really close to that. And so you'll note it's not getting close. It's converging. It's not getting close to this fixed point. It's getting close to this fixed point. So Pn is getting close to the log of 3. What else?
It's just a quick question. On number 8, C and D, letter C, you asked for this a little bit, but I think your quick is
I'm having trouble finding. My exams are all getting mixed up here. Which exam are we on again? Exam 2. Problem.
it's on the last one, the 8, the last one.
Is it the graph?
Yeah, it's the graph.
So it's this one?
Yeah. How did you know where the look was?
Oh, right. Okay, so this was a cobweb diagram example. And obviously, me doing it on the chalkboard is going to be not as good as doing it on paper. Okay. But the thing is, when you do the cobweb diagram, you'll get, so you always start at your initial value, and we started at 1.4, which is about here. Okay. And when I go to 1.4, I get some new value, and I don't remember what the value was. It's in the solutions. And then I go again, and that's not going to be right. It's going to go over and then come down, and then go over and come down again.
Yeah, no, I have that. I just.
Okay, if you draw it carefully, there's going to be a point at which it clearly has to get stuck in a spot where it's being driven towards a point. And wherever it's getting pushed towards, that's the limit. So in this example, it was going to 0.
So you went from your line, all the over, right, and you just like kind of follow it down.
Right, you imagine, I only asked you to go 5. To answer the limit, you have to know that, oh, I have to keep going.
Okay, and what if you didn't go in, you just kind of spiraled, would that be?
If it's spiraled forever, you would say it doesn't look like it has a limit. So the thing about all of these sequences that are defined recursively, they can only have limits of fixed points. So there are only 4 possible answers on this problem. And but you have to see where the cobweb diagram sends you. All right, let's see. What else?
Could you have one on the left exam?
Exam 3, problem 1. This is the summation. All right, so we're solving, we're rewriting this sum as a summation notation. So what that means is we're looking for a sum, k goes from m to n, of some sequence. Okay, so we're going to need a formula for the increments. In other words, we need to come up with a formula that describes those terms. And then we need to know the first index value and the last index value. Okay. Now, a common mistake that students were making is they thought this was the first term and the last term, and they would write 1/4 and 19 over 400, and that's not correct. I'm looking for an index value. So I need to look at these terms and see if I can come up with a simple rule for the value. So 1/4, 2/9, 3/16. And if we're really lucky, maybe we can just call those index values 1, 2, and 3. So let's see, this is 1 over 2 squared. This is 2 over 3 squared. This is 3 over 4 squared. And with a hint, you should have seen something like that pretty easily. So if I thought of this as my k, and this is my sequence, you should have figured out pretty quickly that this is k over k plus 1 squared. And so that's the formula for the increments. Our first index value is 1. What's the last index value? Right, we want 19 over 400 as our value. So what's the k value that matches that? 19, because I need 19 over 20 squared. And so the summation that we should have had is a sum. The index goes from value 1 to 19, and we're adding the sequence k over k plus 1 squared. Yeah?
Instead of having k, if you have an n in place of k, will that still be correct?
Yes, the variable you choose for your index does not matter. So I could have written it as a sum n goes from 1 to 19, n over n plus 1 squared. But you have to have the same formula, sorry, the variable of the index in the formula has to match the one in the summation. All right, and we're not trying to actually find any values. We can't. We don't know how to do that.
So is it like that?
That's it. This is the answer. I'll keep going if you keep asking questions. I won't complain if you stop. Yes.
Number 10 on exam 1, when it was talking about in the context of time and population, what does G of 30 represent? Remember you explained that I forgot what you said about it.
So it's exam 1, problem 10. So let's identify all the variables. We start by saying T is time measured in the number of years since 2000. P is the population size. And so when I say G colon T arrow P, that means G has T as the input, P as the output. P equals G of T. My population is a function of time. When I do an inverse function, it switches the role of the variables. And so what that means is T equals G inverse of P. The input of the inverse is population. The output is T, the number of years since 2000. So when it asks, what is G inverse of 1200? I look at the 1200, and what does the 1200 represent? It's the population. So it says, when the population is 1200, that's the input. What does the function give me back? So what's the output? I'm not asking for a number, just interpretation. It gives T the number of years since 2000. So suppose it gave me back 3. G inverse of 1200 was 3. That would mean it 3 years since 2000, or 2003 was the year. Okay. That sentence would be what I was looking for.
So then if it says like G of 30 represents.
Yeah, so G of 30. So what's the 30 represent?
30 years.
Right, it's been 30 years since 2000. So what does G of 30 give me? This is the population in 2030. I'm really glad I don't teach 4 hours in a row. ever. What are you thinking, Eric? What are you thinking?
I'm wondering if we can do it for 4 hours. Because
Yeah, since 8:30.
since I can hear it.
Because I did this for my other class too.
Okay.
So this YouTube video will be linked to Canvas. So if you want to go back and look at questions that we did talk about, you can go look at that. And good luck studying.